At the stroke of midnight, October 1st, 2025, something unprecedented happens. NASA, the world's leading voice on space exploration, goes silent. The agency's homepage, usually buzzing with live data and stunning images, is replaced by a stark single message: government shutdown. Under normal circumstances, this would be a frustrating but familiar bureaucratic hiccup. But these are not normal circumstances. At this exact moment, millions of kilometers away, the third interstellar visitor ever detected by humanity is entering its once-in-a-lifetime window for observation. And the best seat in the house is Mars. Imagine the timing. Just as the cosmos delivers its rarest messenger, a piece of another star system streaking through our own, the public data streams cut to black. The American eyes in orbit around Mars, our most advanced probes, are still watching. But what they see is no longer being shared. Only a handful of European orbiters and the silent, unblinking lenses of those American assets are tracking this cosmic ghost. The question hangs in the air, thick and unnerving. Is this outage just a perfect storm of political gridlock? A case of terrible, cosmic timing, or is it something more? When the stakes are this high and the silence this absolute, how do you separate coincidence from a cover-up? What aren't we seeing? A rare visitor from beyond our solar system doesn't wait for human calendars. The clock has started. In the pre-dawn hours of October, as the world's most powerful space agency falls silent, a fragment from another star's debris cloud is crossing the orbit of Mars. Think about how incredible this is. 3 times. Only 3 times in all of recorded history have astronomers confirmed an object from another star system passing through our celestial neighborhood. Each arrival was separated by years, each a mind-boggling statistical outlier in a universe filled with predictable, repeating patterns. The odds are staggering. We've tracked billions of comets and asteroids born in our own solar system, their paths dictated by the familiar gravity of our sun. Yet, only a tiny handful have ever traced a path that defies explanation by any known planet or asteroid belt in our system. These are the true outsiders. The value of this moment isn't measured in press releases or trending hashtags. It's measured in the fundamental physics of the universe. Is in the way light bends through the coma, the fuzzy envelope of gas and dust surrounding the object. A coma made of materials from a completely alien environment. It's in the chemistry of its tail, which could betray a birthplace far colder, more violent, or just fundamentally different from anything in our solar system. This is our chance to watch a true outsider interact with a familiar planet, Mars. For a brief, precious window, the red planet, usually a backdrop for our rovers and robotic explorers, becomes the solar system's premier observatory. The geometry is perfect. The visitor's path will sweep within 30 million kilometers of Mars. That's close enough for the orbiters to track subtle changes in its brightness, its color, and its speed. It's close enough to get a detailed chemical fingerprint. Yet, it's also far enough to pose no risk to the expensive hardware we have stationed there. This isn't just a flyby. It's a front-row seat to a cosmic performance that might not happen again for another century. The world's science communities know exactly what's at stake. They remember the last 2 interstellar visitors, Oumuamua in 2017 and Borisov in 2019. Both left us with far more questions than answers. Oumuamua was the first. It was a bizarre, elongated object that tumbled end over end, moving in a way that defied easy explanation. It shot out of our solar system before we could even agree on its shape, its composition, or even its true nature. Was it a new type of comet, an alien probe? The debate still rages. Then came Borisov. It looked more like a conventional comet, but it still challenged our models with its unique chemical makeup and incredible speed. It was a step forward, but we needed more data. Now, with this third candidate, we finally have the opportunity to compare, to contrast, to test our theories and challenge our assumptions about how star systems are formed. This is the tiebreaker. This is the moment that could rewrite textbooks. But the timing is razor-thin. This golden window for observation from Mars is only open for about a week. The closest approach is scheduled for October 3rd. After that, the comet will slip towards the sun, becoming lost in the blinding glare, unreachable by even the most powerful telescopes here on Earth. For planetary scientists, this is a nightmare scenario. A single night of lost data can erase a year's worth of planning. A missed spectrum reading, a gap in the light curve, a failed pointing sequence. Each one of these tiny failures narrows the already slim margin for discovery. Every hour of silence is an hour of lost knowledge, a piece of the puzzle that might be gone forever. The stakes here aren't just scientific. We live in a world where information travels at the speed of light. The complete and sudden absence of official updates from NASA creates a vacuum. And nature, as we know, abhors a vacuum. Into that void, rumors and speculation begin to multiply. People start asking questions. What does the government know? What is being hidden from the public? Who is controlling the narrative? These questions become just as urgent as the scientific data itself. The silence of a government shutdown isn't just a bureaucratic oddity in this context. It's a fundamental stress test for public trust in science and in our institutions. Let's rewind. July 1st, 2025, 3 months before the shutdown. Astronomers using the Pan-STARRS telescope in Hawaii flag an object with an unusual trajectory. It's faint, just a blip on a screen, but its path is hyperbolic, meaning it's not bound by the sun's gravity. It's a visitor on a one-way trip through our solar system. This is a global effort. Scientists from different nations, often competitors, come together. They know this is bigger than any single agency or country. For weeks, the data flows, the object gets brighter. Its trajectory is refined. Everything is building towards this one critical week in October. The public is getting excited. News articles are being written. The world is preparing to witness something extraordinary. Then, the political rumblings begin in Washington. Budget negotiations stall. Deadlines are missed. And against all logic, the unthinkable happens. On the very day the cosmic show is set to begin, the curtain falls. So what happens now? In the silence, unofficial channels become the only source of information. Amateur astronomers with their backyard telescopes strain to catch a glimpse, but the object is too faint and too far for most. Leaks might emerge from within the space agencies, fragments of data, whispered rumors from anonymous sources. But how can we trust them? Without official verification, without the rigorous peer review process, it's all just noise. A blurry image could be a groundbreaking discovery or a digital artifact. An unusual light curve could be a sign of an alien megastructure or just a glitch in a sensor. The European Space Agency is still online. Their orbiter is still collecting data. But they don't have the same high-resolution imaging capabilities as NASA's hardware. They can provide pieces of the puzzle, but not the whole picture. The full story is being written by instruments that are now muzzled. Think of the scientists who have dedicated their entire careers to this moment. They are sitting on their hands, locked out of their own labs, watching the opportunity of a lifetime slip through their fingers because of a political stalemate thousands of miles away. It's a tragedy on a cosmic scale. This scenario forces us to confront a difficult reality. Our incredible ability to explore the universe is fragile. It's tethered to earthly concerns like budgets and politics. We can build billion-dollar probes that travel for years to reach other planets. But their work can be halted by a decision made in a room on Capitol Hill. The next 7 days will decide the legacy of this interstellar visitor. Will it be a milestone of discovery, a moment when humanity learns something new and profound about its place in the universe? Or will it become a chapter of missed chances, a footnote in history defined by speculation and what-ifs? A ghost that slipped through our fingers, leaving us to wonder what we might have seen if only we had kept our eyes open. The universe has delivered a message. The question is, will anyone be allowed to read it? In the vast digital archives of the Atlas survey in Chile, a new entry appears in the nightly search logs. Just another faint speck of light, at first. But as astronomers calculate its orbit from a handful of early positions, something is wrong. The orbit refuses to close. It's not an ellipse, not a neat loop around our sun. Each new measurement stretches the curve further and further out, hinting at a visitor not bound by our star's gravity. A traveler from interstellar space. Over the next 3 months, the global astronomical community mobilizes. Observatories from every continent feed in data, right ascension, declination, photometric points. Slowly, painstakingly, the trajectory is pinned down. The result is undeniable. A hyperbolic path, inbound from the darkness between the stars, heading straight for the inner solar system. The object is named 32 Atlas, the third confirmed interstellar interloper. As October begins, a unique opportunity emerges. From the 1st to the 7th of the month, the geometry lines up perfectly. For exactly 1 week, the interstellar object will sweep through a corridor just 30 million kilometers from Mars. That's a mere fraction of the distance between Earth and the Sun. Suddenly, Mars, usually a silent outpost for our robotic explorers, becomes the best seat in the entire solar system. A quiet frenzy begins. Orbiters and landers already circling or roving the red planet have their schedules scrambled. Science teams prioritize new observation slots, preparing to catch whatever signatures this outsider might reveal as it flies by. The window is incredibly tight. Miss it, and this specific opportunity vanishes, not for years, but for decades. On October 3rd, the moment of closest approach arrives. The object passes at its minimum distance to Mars, a single-point source of light skimming across the thin, reddish sky. Each photon collected adds another line to the growing ledger of our interstellar encounters. By the end of October, from the 29th to the 30th, the comet reaches perihelion, its closest point to the Sun. It rounds our star at a distance of about 204 million kilometers. From our perspective here on Earth, the object is completely lost in the Sun's blinding glare. Even Mars has lost its prime vantage point. Only a few specialized spacecraft positioned far from the Sun's light, like the European Space Agency's JUICE mission out at Jupiter. Every date is stamped, every distance logged, and every observation is now ready for the long process of verification and analysis. Behind the scenes, the sheer scale of this coordinated effort is staggering. Inside the Mars science community, every single asset and operator finds their role defined by the clock and the sky. The European Space Agency's campaign order goes out first. Two of their key orbiters, Mars Express and the ExoMars Trace Gas Orbiter, are tasked with high-cadence comet tracking for the entire week of the flyby. Teams for the High-Resolution Imaging Science Experiment, or HIRIC, and the CRISM spectrometer aboard the Mars Reconnaissance Orbiter receive last-minute observation windows. Their requests are logged, but held behind a firewall of legal silence due to a government furlough. Meanwhile, the MAVEN spacecraft, designed to study the Martian atmosphere, pivots its instruments. Each observation approval had to be routed through national science boards. Each exposure was a small gamble on unpredictable factors: space weather, spacecraft health, and the unknown brightness of an interstellar visitor that had never been seen before. This global collaboration represents a fundamental shift in how we explore space. It's no longer just about one agency or one nation. When a visitor from another star system arrives at our doorstep, we all look up together. This object, 3-2 Atlas, is more than just a rock or a chunk of ice. These are the questions that drive the hundreds of scientists and engineers working around the clock. The data from this flyby will be analyzed for years, even decades to come. Every piece of information, from its trajectory to its chemical makeup, will help us build a more complete picture of our place in the universe. It reminds us that our solar system is not an isolated island, but part of a vast, interconnected cosmic ocean. And sometimes, fascinating things wash up on our shore. Picture this: it's just past midnight on October 1st. A federal law, the Anti-Deficiency Act, kicks in, and just like that, NASA goes silent. Its public voice is completely shut down. Websites, social media, press offices, everything goes dark. Why? It's not some cosmic conspiracy. It's a government shutdown. The law is simple: no approved funding, no work. Unless, that is, the work is essential to protect life or property. For NASA, this creates a bizarre situation. A tiny loophole allows flight operations to continue, protecting billions of dollars worth of spacecraft. So probes like the Mars Reconnaissance Orbiter and MAVEN keep working. They're still collecting priceless data, their commands sent through secure channels. But outside of mission control, there's a total blackout. Hundreds of employees are sent home. Public outreach teams, the people who share NASA's incredible discoveries with us, are locked out of their accounts. They can't post a single update. It's a complete firewall. The data is being collected and archived, but it's not being shared. Health checks on the spacecraft are done in secret. Calibrations happen, but no one outside knows. The official NASA website just has a stark banner: NASA is currently closed due to a lapse in government funding. For us, the public, the effect is immediate. No new images from Mars, no press briefings, no live commentary. There's an interstellar object passing by the red planet, a major astronomical event, and all we get is silence. It's not a glitch, and it's not a cover-up. It's the cold, hard reality of legal code. The science continues, but the story, the narrative that connects us all to the cosmos, is put on hold. But here's where it gets interesting. While NASA is muzzled, a global network of observers, from professional agencies to backyard enthusiasts, is watching the skies. The story starts with a citizen astronomer Priya Ralo. From her own backyard, she noticed something strange. A dip in the light coming from an object dubbed Atlas. Her discovery, her real-time measurements submitted to the Minor Planet Center, was the first red flag. Her data might not have the precision of a billion-dollar space telescope, but it fills a crucial gap. It's a powerful reminder that the sky belongs to everyone. No single agency owns the stars. From the European Space Agency's operations directors to the overnight crew of the Red Watch team, everyone is working on a razor's edge. They have 1 week, one single chance to observe this object. There's no guarantee of a second look. The entire infrastructure is global, the protocols are strict, but it's the human element, often silent and invisible, that ties it all together. It's the common thread in every single data point. And it's this human network that will outlast the government-mandated blackout. While NASA's public-facing side is frozen, their Red Watch crew is deemed essential. They work through the shutdown, their every move documented, every shift change notarized. Every single action is logged for internal records only. The firewall is absolute. For 7 days, a fleet of the world's most powerful telescopes orbiting Mars turns its gaze toward a single, unresolved point of light in the darkness. Every asset is focused on this one mystery. ESA's Mars Express, the ExoMars Trace Gas Orbiter, China's Tianwen-1, the UAE's Hope Probe, and of course NASA's own MRO and MAVEN. All of them, an international coalition of machines, become simple photon counters staring at the same spot. The data keeps flowing into secure servers, but the story is trapped behind a wall of legal jargon. The mechanics of discovery are in full swing, but the human narrative, the awe and wonder of it all, is suspended. It's a story paused not by the limits of science, but by the lines of a statute. It's a stark illustration of how our exploration of the universe can be held hostage by earthly matters. But it's also a testament to the resilience of human curiosity, a force that finds a way to keep watching, even when the official eyes are forced to look away. In the vast, cold silence of space, a visitor from the outer dark was making its way through our solar system. An object, designated 3I, on a path that would bring it close to Mars, and just as it reached this crucial point, a window of observation for our Martian orbiters, the world went dark. Not a cosmic event, but a terrestrial one, a government shutdown. For 7 days, NASA missions went silent, and a data blackout fell over the Atlas comet's Martian encounter. What happened in that week of silence? What secrets, if any, are hidden in the data logs that are only now beginning to see the light of day? From Mars, our robotic eyes were watching. Probes from the European Space Agency worked from pre-approved scripts, methodically logging data. They measured the comet's position with incredible precision, a practice known as astrometry. They captured its brightness as it spun through space, creating what we call light curves. And if they were lucky, they'd catch a faint trace of gas, a whisper from the comet's coma. But the heart of the comet, the nucleus itself, remained a mystery. Smaller than a single pixel, an unresolved dot no matter how long the exposure. What came back were numbers. Pure raw data. Brightness levels rising and falling, hinting at the object's rotation. Color data that suggested the presence of ice or dust. Spectrographs strained to catch the faintest signature of carbon, water, or maybe, just maybe, something stranger. Each measurement was a single, isolated fact, a data point waiting for context, waiting to be woven into a story once the blackout finally lifted. But here on Earth, in the vacuum of official updates, that silence became its own kind of signal. It created a void, and human nature rushed in to fill it. Social media threads exploded with speculation. Some theories were reasoned, based on what little we knew. Others were wild, fueled by the lack of information. Screenshots of the European Space Agency's last blog post before the shutdown were passed around like sacred texts, placed alongside grainy amateur plots from backyard astronomers. The hashtag Atlas blackout started trending. Rumors swirled, each one feeding the next. Was it 3I, the third interstellar object ever detected, or not? The lack of detail was a breeding ground for myths. Some claimed the silence was a cover-up, hiding a monumental discovery. An anomalous spectrum, perhaps, or a trajectory that just didn't fit our understanding of physics. Others, more pragmatic, insisted it was simply bureaucracy in action, a poorly timed shutdown that just happened to coincide with a once-in-a-generation cosmic event. The frustration was palpable because everyone knew the limits of our technology. No camera at Mars could actually see the nucleus of the comet. No spectrometer could do more than pull out the very brightest gas lines, and only if the coma conveniently flared up at the right moment. All we could ever hope for were those light curves, positional data, and fuzzy, low-quality spectra. But in the absence of new data, every missing update, every unexplained gap in the observations became fuel for new theories. The life cycle of these rumors was short and relentless. A single ambiguous post could trigger hundreds of replies, each one a step further from the cold, hard facts being logged millions of miles away. As the week dragged on, the digital ledgers on Mars filled with raw numbers, but the story being told back on Earth was one shaped entirely by uncertainty and imagination. The real challenge wouldn't be analyzing the data, but sorting the natural anomalies from the narrative inventions that had taken root in the darkness. So, as the Mars window closed and the comet continued its journey, 6 competing explanations emerged from the noise, each trying to account for the week of silence. The first, and by far the most probable, is simple bureaucratic coincidence. A government shutdown, dictated by fiscal calendars completely indifferent to cosmic timetables, happened to overlap with a rare but perfectly natural celestial encounter. Nothing more, nothing less. The second explanation looks to the environment itself. Could the solar wind have flared up? Or maybe some strange atmospheric anomaly on Mars interfered with the data transmission. A brief, natural blip that could easily be mistaken for a gap in coverage or something more mysterious. It's a plausible, if less exciting, possibility. The third theory is where things start to get more speculative. What if this wasn't just any comet? What if its nucleus was unusually massive, or rich in metals? The kind of object that would light up a spectrometer in unexpected ways or even subtly bend its own trajectory. Something no comet from our own solar system has ever been seen to do. The fourth idea dives headfirst into conspiracy, black budget data capture. This theory suggests that classified science operations were running in parallel to the public ones. That while the public-facing channels were silent, a different set of logs, in places we cannot see, were being filled with groundbreaking data, reserved for a select few. Fifth on the list is the third-party intercept. This scenario imagines technology beyond any known agency from another country or a private entity, swooping in to capture or interfere with the data. It's a plot straight out of a spy thriller, but a theory with absolutely no evidence and no precedent in the history of space exploration. And the sixth, the most extraordinary and most captivating explanation, is that this was an engineered artifact. An object that was built, not born. A probe or a vessel, crossing the vastness of our solar system under a clever disguise of dust and ice. Each step down this ladder of explanations demands a higher and higher burden of proof. From simple coincidence to an alien probe, the rigor required to prove the case grows exponentially. So how do we cut through the noise? How do we separate fact from fiction? We use a checklist. A receipt list, built for rigorous audit, not for arguments on the internet. First, we check the Minor Planet Center's orbital updates. These are public logs that detail the comet's path, its speed, and its trajectory. Is it following the expected hyperbolic curve of an interstellar visitor? Next, we need the data from the European Space Agency's missions, Mars Express and the ExoMars Trace Gas Orbiter. The raw images, the spectra, the pointing logs, the exposure times, all of it should be archived and made public in the Planetary Science Archive. Then comes NASA's post-shutdown data release. Every command sent, every bit of data downlinked, and crucially, every gap in that data needs to be explained in the mission logs. Was a gap caused by the orbiter passing behind Mars, or was it something else? Finally, we need observations from Earth. After the comet passed Mars, ground-based telescopes would be watching. Their light curves and spectra need to be cross-checked against the predictions made from the Mars data. Consistency is key. If the data from Europe's probes at Mars, NASA's logs, and telescopes on Earth all tell the same story, a smooth hyperbolic orbit, ordinary cometary gases, and no weird accelerations, then the case is closed. What would be a smoking gun? A real, undeniable anomaly? It would be a Doppler shift that doesn't make sense, indicating a change in velocity that gravity can't explain. A trajectory that simply refuses to fit the models. Or spectral lines showing elements or compounds that defy known chemistry. Anything less than that is just noise, not a signal. The standard for declaring an anomaly in science is incredibly strict for a reason. Anything that survives this gauntlet of scrutiny moves from rumor to the scientific record. Everything else, the gaps in the light curve, the missing images, the ambiguous spectra are just the normal scars of doing science at the very edge of what's possible. They are not evidence of a conspiracy or a cover-up. The receipts, when they are all made public, will decide which story holds. And here's what we know so far. Throughout that 7-day blackout, Mars-based assets like ESA's Mars Express and ExoMars did continue their observation campaigns. NASA's missions also remained operational. They were just legally prohibited from communicating with the public. No credible evidence has emerged of any interference beyond the documented shutdown protocols. Yet that absence of real-time data became a petri dish for speculation. It was a perfect storm, a powerful demonstration of how routine government policy and a rare cosmic event can collide to amplify rumors and erode public trust. The checklist for truth remains. The published data from the European Space Agency, the orbital updates from the Minor Planet Center, and NASA's own post-shutdown logs will ultimately confirm or refute any claims of an anomaly. As of right now, all publicly available data show a perfectly normal interstellar comet on a smooth, predictable path, exhibiting ordinary cometary behavior. Are there still unanswered questions? Yes. Some details about the observations and why certain decisions were made may remain unclear until all the data and mission logs are released. This whole episode has been a stress test for scientific transparency in the age of social media. It's a stark reminder that silence does not automatically equal suppression. In the end, it will be the records, not the rumors, that decide what history remembers about the visitor from the stars and the week the Earth went quiet. Thanks so much for watching. If you found this journey through data, rumors, and cosmic mystery as fascinating as I did, don't forget to hit that like button and subscribe for more deep dives into the universe. See you next time.